We import TensorFlow as TF. Then we print out what version of TensorFlow we are using. We are using 1.0.1. Next, let's import NumPy as NP, and then print out what version of NumPy we are using. We are using NumPy 1.13.3. In this video, we're going to create a placeholder tensor using the TensorFlow placeholder operation. No data will be provided for the tensor until the execution within a TensorFlow session. At that point, we'll use a feedDict argument, which will provide the data that will fill the placeholder tensor. Alright, let's get started. In order to do that, let's start by defining a TensorFlow placeholder tensor that will eventually hold data of data type 32-bit signed integers and have a shape of 1 by 2 by 3. We create this placeholder tensor using the TensorFlow placeholder operation and assign it to the Python variable placeholder underscore x. So you see TensorFlow.placeholder, we give it the data type, tf.int32, and we give it a shape of 1, 2, 3, and we assign it to the Python variable placeholder underscore x. When we print out what our placeholder example Python variable has, we see that it's a tensor, it's a placeholder, the shape is 1, 2, 3, and the data type is int32. Let's also define a TensorFlow addition operation where we add this placeholder tensor to itself. We create the addition using the TensorFlow add operation and assign it to the Python variable placeholder underscore sum underscore x. So we use TensorFlow.add, placeholder underscore x, comma placeholder underscore x, and assign it to the Python variable placeholder underscore sum underscore x. Let's print out our placeholder sum example Python variable to see what's in it. We see that the operation is add, the shape is 1, 2, 3, and the data type is int32. Because TensorFlow's add operation does element-wise addition of tensors, this makes sense. Now that we've created our TensorFlow variable, it's time to run the computational graph. We launch the graph in a session. Then we initialize all the global variables in the graph. Now that we've done that, let's print our placeholder underscore x tensor in the TensorFlow session to see the values. Yikes! We get an error that says, you must feed a value for placeholder tensor placeholder with d-type int32 and shape 1, 2, 3. A TensorFlow placeholder tensor is just that, a placeholder, so printing it doesn't make any sense and that's why we get an error. Let's also check out the placeholder underscore sum underscore x tensor in a TensorFlow session to see the value. We get the same thing. We get an error that says you must feed a value for placeholder tensor placeholder. This is expected because placeholder sum x is just the sum of the placeholder tensor with itself, so having it not have any values when we evaluate it, adding it to itself would definitely still not have any values. So to properly use the placeholder tensor, we have to pass a feed underscore dict to it. Since we know the placeholder is an int32 tensor expecting a 1 by 2 by 3 shape, we can create a NumPy multidimensional array to feed into it. And to do that, we're going to create a 1 by 2 by 3 NumPy array filled with 1, so we're using numpy.ones, and we're going to give it the data type int32, and we're going to assign it to the Python variable mda underscore x. Now that we've done that, let's print the evaluation of the placeholder sum x when we use this mda underscore x array in the feedDict. So we see print session run placeholder sum x, and for the feedDict we're going to pass in the placeholder x. We want to use this NumPy multidimensional array. When we do that, we see that the result is a 1 by 2 by 3 tensor whose value is all 2s, which is what we expect because the placeholder tensor was full of 1s, so when we added it to itself, 1 plus 1 is 2, and because it's element-wise addition, all the element places are the integers 2. Finally, we close the TensorFlow session to release the TensorFlow resources used within the session. And that is how you create a TensorFlow placeholder tensor, and then when it needs to be evaluated, pass a NumPy multidimensional array into the feedDict so that the values are used within the TensorFlow session to fill out the TensorFlow placeholder tensor.